Chapter 4 is about polynomials of a higher power than just quadratics. And I would have printed you out notes, but the printer is dying as it's shifting between the staff rooms at the moment. These are green boxes, they're in your textbook, so don't feel a panic need to copy them down. I'll just talk you through them. This looks really freaky, but it's the form of a polynomial. These are called the coefficients. A to the n, take 1. Different coefficients heading down. This leading one by definition isn't 0. Then there are powers, and the powers are usually reduced. So we're used to seeing x squared, x to the 1, and x to the 0, but it could be anything. It could be x to the 5, x to the 4, x to the 3, etc. These are the common polynomials we'll be dealing with. Linears and quadratics you've met before. Cubics you might have had a bit of a play with, but then there's also quartics and quintics, and then powers of 6, 7, 8. All of them follow the same type of pattern. We say their degree is the power of the highest x. So this is a degree 4 polynomial, also known as a quartic, or a degree 3 polynomial, also known as a cubic. Very much definitional stuff. And when you look at 4a.1, it's literally asking you to name the polynomial function, or state the leading coefficient. If that was 5x to the power of 4, the leading coefficient is that 5. It's the most powerful coefficient there. Where we start doing a little maths is when we compare polynomials. So ignore that basically. If you have this, 2x cubed, 3x squared, take 4x plus 6 equals ax cubed plus bx plus c, etc. plus d. If they are the same, their coefficients must be the same as well. It's called equating coefficients, meaning that if there's an x cubed here and there's a 2 in front of it, over here the x cubed must also have a 2 in front of it. Therefore a is 2. If here is an x squared with a 3 in front of it, b is 3. It's the only way these can be equal is if the coefficients of each power of x are equal. It's one of those cool things where we can solve multiple unknowns from one equation. Normally we're thinking 2 unknowns, we need 2 equations. Here, good news, we can solve many off one. Where that tends to come out is in questions like this. So this is really the only question we'll need to do for the day. Well, you'll need to take notes from for the day. Can you please copy that one down? There are 2 ways to do this. Do you guys want the long easy way or the short harder way? Short hard. Alright, I'm going to write long easy here, and then over here short hard. Knowing how to take a shortcut is actually very useful sometimes. So we're going to pull off the short hard way to start with a couple of shortcuts. The shortcut is recognizing you don't fully have to expand this. The only way to get an x cubed out of this expansion is this x times that x squared will get me an x cubed. No other combination will get me x cubed. I can't do like 5x times bx and get a cubed out of it. It's just going to get me a squared. Given that that's the only way I can get an x cubed, what does a have to be for that to end up there?
1.
Yes. So we aim for low-hanging fruit first. A is 1. We can read it off. Now, how do you get a constant out of this? A constant is where there's no x's involved. 2 times c is the only part of this expansion where no x's will appear. Given that, what's c? Lovely. C is negative 3. It is negative 3, right? Yeah. Alright. Now, I don't want to fully expand it because we're going the short hard way. I want to pick on one. I'm going to try and solve for b. And I'm going to use something we haven't used already. I'm going to use this minus 7x. So, minus 7x on one side will equal to the x's on the other side. So I guess here, how do we expand to get an x? Well, we expand to get x's by doing 2 lots of bx. That would get an x in the expansion. What other expansion will just get us an x term?
5x and the c.
Good. The 5x and the c, and we know what c is, right? Because we've already solved it. C is minus 3. So you happy if I write minus 15x? Yeah? And no other combination will just get single x terms. I can't do like the 5x and the bx. I can't do the 2 and the c. Only that pair of expansions, the 2 and the b, the 5x and the c, are going to get a single x term. So this must be true. Once we reach here, you can really cancel out the x's. And what we're looking at is minus 7 equals 2b minus 15. And from there your life gets easier. So what would b be?
4.
4? I like 4. I'm going to add 15 to give us an 8 divided by 2. b is 4. And then finally, we're after k. Now, k is already on its own, kx squared. I need to pull out where I'll get x squareds from here. I'll get x squareds by doing 2 lots of ax squared, and we know a is 1. So I know this is the same as 2x squared. How else do I get an x squared out of the expansion? I was going to epically foil it.
5bx squared.
Good. It'll be 5bx squared, and we know b is 4. So 5 times 4 will give me 20x squared. So therefore, what is k?
22.
Lovely. 22. And that's the answer. Did you want me to do this way as well? I think I should for completeness' sake, just for the sake of it.
Are you just going to expand it and then simplify it?
I'm going to expand it. So it'll be 5ax cubed plus 5bx squared plus 5cx plus 2ax squared plus 2bx plus 2c. Then what I'm going to do is collect things together and pull out the x's. And I'll show you what I mean. 5ax cubed plus bracket 5b plus 2ax squared plus bracket 5c plus 2bx plus 2c. What I've done is I've put the x squareds next to each other, there and there, and I've put the x's next to each other, there and there, and then just factored out the x squared and the x's. The reason I've done it is because now we can start comparing it to the first line. I know that 5a is equal to 5. Cool, a is 1. I know that this is equal to this. Cool, c is minus 3. Because I know c, I know that this is equal to minus 7. And I know that this, now we have that r, a and b, is equal to k. And you can sort of see where we were getting this from in the first place. So how you do it, I'm not fussed. I think being able to see how both ways will work will be kind of useful. Makes sense? So today,
I think when we do this one, we can use the shortcut first, and then when we want to check it, we can use the long way, so it's like we don't lose anything or do it wrong.
I agree. Today, keep going with 4G and H. I know some people were looking at it before camp. They are the harder ones. Then have a look at chapter 4, because polynomials sound really scary, but they're not. Look at 4a.1, but don't do it. It's insultingly easy. 4a.2 is 3 questions similar to this. So have a shot at them. And the goal is, I think our next lesson is next Tuesday. Is that right?
Yeah.
I would love it, and I'll post it on Canvas, if these were done in time for next Tuesday. Yes?
Next Tuesday is the exam.
No. Listen.